Okay, this is number 12. So it's asking the limit as x approaches 3, which is in general. It's not specifically left or right. So look at 3, your x value 3. Here it is. Here it is. Okay? Now as you approach from the left, limit 0. As you approach from the right, limit 0. Now as an added bonus, the function value is 0 too. So like all three line up. So that just kind of really drives home the point that the limit 0, but you wouldn't need this. So let's say, for instance, let's say you had an open hole here. So I'm going to color in. I'm going to make it an open hole. Let's say the open hole was right there, and there was actually a dot, say, way up here. The limit would still be 0, even though you have an open hole. Because I'm not looking at 3. I'm looking as x approaches 3. But I'm sorry, I wrote a 3 here, but I meant that the limit is 0. The limit as x approaches 3 is 0. Okay, that's the first part. Okay, now let's look at the second part. As x approaches 8. So again, as x approaches 8, look for 8 in the domain value. Ooh, got an alarm bell setting off. We have a break in the graph. As you approach 8 from the left, the limit goes, yeah, it's 1. So as you approach 8 from the left, your y values say, man, I got really close to 1. And of course, the function value at 8 is 1. Not that I care about that. As you approach 8 from the right, we got a problem. So you approach 8 from the right, the limit says I'm 3. Left says 1, right says 3. 1, 3, 1, 3, 1, 3. They don't agree, so the limit does not exist. Left and right, remember, if the left doesn't agree with the right, it does not exist. Your limit in general doesn't exist, so it'd be option B. Alright, the last part, let's look at the limit as x approaches 4. So again, we look at 4. Now, I sometimes have a little bit of caution because it's like there is this sort of discontinuity here. If you remember discontinuity from section 2.3, it's just one little point that's off. Remember, this is the function value at 3. So this is function value at 4. But as I approach the limit, pretend like there's a fog here. Okay, there's this haze. You can't see what this graph does at 4. It's all hazed out. It's fogged out. Okay. You can only kind of predict based on, okay, as I approach, this is 3.1, 3.2, 3.9, 3.9 repeating, 3.9 as much as I want. As I get really close to 4, I would think my function value is almost 4. That's how it behaves from the left. It behaves the same way from the right. So, if I get rid of this fog here, alright, I don't care that the function value at 4 is actually just jumps and is removed. The limit as I approach 4, either left or right, is going to be 4, even though there's an open circle there. So, our limit as x approaches 4 is going to be just the number 4. So, our limits are 0, this one doesn't exist, and as x approaches 4, limit's 4. That's the complete all parts of number 12.